All right, so exercise 4, oh no. Exercise 4 has us looking at another situation where we're going to create a probability distribution. This time I flipped the distribution a little bit. Instead of having x as a row and px as a row, I have them as columns, but it's the same thing. So we have a student taking a quiz with 4 questions. Each of those questions has 5 options. Unfortunately, our student has not reviewed the material and has to guess on each question. So x is going to be the number of questions the student guesses correctly. So the first thing we had to do is figure out what our x's are, right? How many questions could the person get correct? That's part 1. If there are 4 questions, we're going to go from none up to all, as always. So we get 0, 1, 2, 3, or 4 of them correct. So this would be the best case scenario. He somehow manages to get 100% despite not knowing anything. And then the worst case scenario, he might as well just stay at home. So now we need to figure out the probability for each of those things. Now, just like in our sampling questions, each of these is a random event. And we have 4 of them. So we're going to have 4 different things that we're going to be looking at, right? 4 different questions. If he gets 0 of them correct, that means every single one was incorrect. So let's just do this same work for every single one of these. 2, 3, 4. Have our 4 questions. So all of them would be every single one correct. And then remember, I like to just have whatever I'm looking for come first. So 1 correct, that means the rest are incorrect. 2 correct means the rest are incorrect. 3 correct means the last one is incorrect. Now, we can figure out the probabilities for each of these things. The probability of a student getting a question right, well, if it's 5 options, it's a 1 in 5 shot, right? That's the probability of getting the question correct, which means the probability of getting it incorrect is just 4 out of 5. I'm going to redo these as decimals just to make my life easier. So 0.8, 0.8, 0.8, and 0.8, up to 0.2, 0.2, 0.2, and 0.2. Now the one thing we have to pay attention to, because this is basically a sampling question, right, is how many ways can these things be ordered? For none and for all, where it's all I's or all C's, there is only one way to order this. So we don't have to have any multiplier out in front, but we'll put a 1 there just to make sure everything stays pretty obvious. For getting 1, well, we've done this a lot when we get exactly one thing that we're looking for. This correct problem could have happened on number 1, 2, 3, or 4. So there's 4 ways for this to happen. And that's also going to be true for the 3, right? Except for now we got one problem incorrect. It could have happened in the 4th, 3rd, 2nd, or 1st. So this also has 4 ways to order. The hardest one is going to be dealing with 2 correct. So I urge you to take a moment, pause the video, see if you can figure out how many ways there are to order this particular question. Obviously, we could just sum all of these up, because they should sum to 1, and see what this value is. But let's try to figure out what that value is. So if you paused, hopefully you started doing this, okay? Well, maybe you moved over once, and then again. Maybe you went, well, maybe the second one is the correct one. And then maybe the 3rd one. So it turns out there are 6 ways for this to happen. And I'm just going to go ahead and rewrite these all so we can start looking at this pattern that happens. So the first one is just going to be 0.8 to the 4th power. The next one is 4 times 0.2 times 0.8 to the 3rd power. So hopefully you're seeing the pattern that's occurring here. So as we look at the 0.2s, 4, 3, 2, 1, and technically if we wanted to, there's a 0.2 to the 0 on the top one, right? And same thing with the 8s, the 0.8s. The 80% goes 4, 3, 2, 1, and then technically there's a 0. So what you're seeing here is the binomial distribution, which is the next section, and what your quiz is going to be on, or your worksheet is going to be on, in class next week. So let me just give you the values for this. So as you can see, it's equally likely that he either gets 0 or 1 correct. And overall, it's almost an 82% chance of that happening. The chance of him getting all of them correct is very, very, very slim if he is guessing. So the last thing we can do here is figure out our expected value and that standard deviation. So we could all use our calculators to do that thing we had just done, right? I'll go ahead and do that for you guys. So in this case, just to see the calculator shortcut again, if you have that set, you don't need to keep watching, but if you want to see it again, here's the calculator. Boom. Let's clear these out. And we have 0, 1, 2, and 4. And whoops, I need those probabilities. And this time, since I didn't show it before, I can show you guys me checking that n is equal to 1. And I'll talk to you again about what the different mistakes would look like if it wasn't equal to 1. Alright, so that looks good. Stat, one var stats with L1 and L2. My mean is 0.8, and my standard deviation is also 0.8. And as I was saying, you can double check that this is right by looking at that n equal to 1. So if you had forgotten to do L1 and L2, so if I had done my one var stats but I hadn't entered in L2 here, you can see an n is 5, and we're getting out a mean and expected value that don't really, or mean and standard deviation that don't make sense. And the other way that this might have had a problem is if I had one of these entered wrong. Like let's say I accidentally added an extra decimal here. If I went to do my one var stats on this, with L1 and L2, you can see my n is just slightly off. It's not 1 because I'm not summing up to 1. So that's the easiest way to check that you've done this properly.